Good day. So today is a very rainy day because of the arrival of Typhoon Upong in the Philippine area of responsibility. So in preparation in case of inclement weather conditions and bad internet connection, I'm recording this lesson for logic. So first, let's review the lessons last time and then proceed to the lessons that should be covered today, Okay. So let's say that P is the first statement, and we say that Typhoon Upong is in the Philippine area of responsibility, and you have statement 2, Q, which is it is raining hard. Then if we're going to create the truth tables for these statements, then we need to have 4 rows because that's 2 raised to 2 in as discussed previously, where there are 2 statements, so that's 2 raised to 2 since each statement has 2 possible truth value, that is true or false. So you need to have 4. Okay. So we begin with statement 1. So for the Typhoon Upong is the Philippine area of responsibility, either that's a true statement or a false statement. So you have 2 rows for true and 2 rows for false. And then for statement 2, we also have 4 possible values for that. So it is raining hard. So either that's true or false or true or false. And this is now the combinations if we have 2 statements. So both statements are true. The first statement is true, but the second one is false. The first statement is false, but the second one is true. And both statements are false. Okay? And then so these are the usual values for a truth table with 2 statements. So to proceed to the next, we now get the negation of the first statement. So we have now not P and a negation of the second statement, not Q. And since the negation is simply the values or the truth value for the statement or the opposite truth value of the given statement, so since the first statement gives us true, true, false, false, so its negation should be false, false, true, true. So since this is true, so this is false, true, false, false, true, false, and then true. Same is true for the negation of the second statement. So since this is true, false, so this is now false, true, false, true. So this is true, this is false, this is false, this is true, false, false, and then true. Okay, and then we're going to be using, not yet, okay. And then we're going to be using this statement again for our next portion, which are the compound statements, using our 2 compound statements that can be created using these 2 statements. Okay, so you have your conjunction, disjunction, conditional, and biconditional statements, so which are our possible compound statements using 2 simple statements. Again, our simple statements are P, Typhoon Upong is now in the Philippine area of responsibility, and Q, it is raining hard. So for P and Q, so that's Typhoon Upong is the Philippine area of responsibility, and it is raining hard. Okay, and for and, the rule for this one is that both statements should be true to make it a true statement. So if one of the statement is false, automatically the and statement is false. Okay, so for the first row, since P and Q are both true, then we write that P and Q is true. And then for the second statement, since the second statement is false, so we write this one as F. And then since the first statement is false, so we write this one as false as well. And for the last 2 rows, since both statements are false, we write that one as false. For example, if we replace that one with Typhoon Upong is in the Philippine area of responsibility and it is raining hard, and we know that that's true, or this is true, the first statement is true, and the second statement is true as well, so P and Q is true. But if one of them is you stated that one of them is false and you know that it's not true. Like, for example, F1 Upong is in the Philippine area of responsibility and it's not raining hard. So this is now a false statement. Then you have the disjunction statement. The disjunction statement is the or statement, and the rule for disjunction is that the or statement is true if one of the statements is true. So if one of the statements is true, since it's a choice, then it's true. So for P or Q, for the first row, since both statements are true, so this is true. So the second statement, the second row, is true or false. So since the first statement is true, so this is true as well. In the third row, since this is false or true, and the second statement is true, so P or Q is true. And in the last row, this is false or false, and since both statements are false, so this is also false. Okay? So since it's or, Typhoon Upong is in the Philippine area of responsibility, or it is raining hard. If one of these is true for you, then that's a true statement. Otherwise, it's a false statement. Next is the conditional statement. So the conditional statement is a if-then statement where the first statement is called the premise and the second statement is now your conclusion. And then for P implies Q, we read this one as P implies Q. Then the rule for this one is that the premise, conclusion should follow from the premise. So the conditional statement is false if the first statement is true but the second statement is false. For example, if this is our statement, if Typhoon Upong is in the Philippine area of responsibility, then it is raining hard. It is a true statement. But if you say that Typhoon Upong is in the Philippine area of responsibility, then it is not raining hard. And if this does not follow from the first statement, then we might say that this is a false statement. So this is now true. And since this is the rule that we follow for conditional statement, where the first statement is true and the second statement is false, so this is now false. And then, if we cannot make sure that the conclusion actually follows from the premise, so that's the Aristotelian logic, that if you cannot verify since you cannot verify actually if the conclusion follows from the premise, since the premise is false, we assume that the statement is true. So, innocent until proven guilty. So, most of these statements are true. And lastly, for the biconditional statement, it's a conditional statement that's wherein the premise and the conclusion and the should agree with one another. So it's a biconditional statement. For example, Typhoon Upong is in the Philippine area of responsibility if and only if it is raining hard is a true statement because both statements are true. Okay, so if one of the statement is false, like true, if and only if false, so this is now false. And for the third row, since this is false, if and only if true, so this is false as well. But if Typhoon Upong is not in the Philippine area of responsibility, if and only if it is not raining hard, then it is also a true statement. Okay, so again, for conjunction, it's only true when the first statement is true. When both statements are true, rather. And then for disjunction, it is true if one of the statements is true. For the conditional statement, it is true most of the time, except for when the conclusion do not follow from the premise. So when the first statement is true and the second statement is false. And lastly, for the biconditional statement, it's true if they have the same truth value. So the rest of the time, it will be false. Now we go to the variations of the conditional statement. So it's the conditional statement, the converse, the inverse, and the contrapositive. And since this is a conditional statement, it also follows the rule that if the first statement is true and the second statement is false, then that's a false statement. So we start with P implies Q. So this is our first statement, and this is our second statement. So we check. So which of the statements are true? So that's P and the first two rows. And then we check which of the statements is false in Q. So that's the second row. So this is now false. And the rest of the statements is now true. And then we go to the converse. The converse is just the opposite of the if you exchange the premise and your conclusion for your statement. For conditional statement, P implies Q. So that's if Typhoon Opong is in the Philippine area of responsibility, then it is raining hard. And for the converse of that one, since this is Q implies P, then if it is raining hard, then Typhoon Opong is in the Philippine area of responsibility. And so the first statement now is the Q, and the second statement now is the P. So we check which of the statements in Q are true. So that's the first and the third row, and then we check which of these is false for which of the statements in P are false for the true statement. So this is now the third row. So the first statement is true, that's in Q, and the second statement is false, that's in P, and that's in the third row, so the third row is now false. And then the rest of the statements will be true, since this is a conditional statement. And then now we have the inverse of the conditional statement, wherein we negate the premise and the conclusion. So it follows the same order as the conditional statement, just that it's using the negation of P and the negation of Q. So we read this one as, if Typhoon Opong is not in the Philippine area of responsibility, then it is not raining hard, if using this statement. Okay? The first statement now is not P, and the second statement is not Q. So the same as your rule for conditional statement, we check which of the first statements is true, and then we check which of the second statements is false. Okay, so that's the third row as well. So this is now false, and then the rest of the statements are true. And now we have the contrapositive. So the contrapositive is the converse of the inverse. Or you go use the negation of your Q and P for that one. So this is now not Q implies not P. So if it is not raining hard, then Typhoon Opong is not in the Philippine area of responsibility. Okay, so the first statement now is Q. Again, we check which of the statements are true. So that's the third and that's the second and the fourth row. And then we check which of these two statements is false in P, since not P is our second statement. So that's now the second row. So this is now the false statement, and then the rest are true, since this also follows the conditional rule. Okay? So this is now the truth table for your conditional statements. Okay? And then after that, we'll be discussing logical equivalence. Okay? So logical equivalence is when the truth table of your statements have the same truth value all throughout. So it's a match. So for example, this one, both statements are true in the first row, both statements are true in the second row, both statements are false in the third row, and both statements are true in the last row. So the converse and the inverse are logically equivalent. Okay, so if it is raining hard, then Typhoon Opong is in the Philippine area of responsibility, means the same thing as Typhoon Opong. If Typhoon Opong is not in the Philippine area of responsibility, then it is not raining hard. Okay, so that's one logical equivalence relationship. And then the other one is the conditional and the contrapositive. So if you look at this one, the first rows is true and true. The second is false and false. The third is true, and the last one is true and true as well. So the conditional statement and its contrapositive. So if Typhoon Opong is in the Philippine area of responsibility, then it is raining. It is raining hard. Means the same thing as saying that if it is not raining hard, then the Typhoon Opong is not in the Philippine area of responsibility. Okay, so these two are actually also logically equivalent. So to practice more for logical equivalence, you have these relationships here. So we have not P and Q and not P or Q. So for P and Q, we simply copy the values of P and Q here. It will not change since we are using the same truth tables for PQ, not P and not Q. So you simply copy that one. And then we get the negation of this one. So to get the negation, we simply give the opposite truth value. So for true, that is now false. For false, that is now true, true, and true. And then we have or here, diba? Or for not P and Q. So this is P and this is Q. And since this is or, diba? If in or, the rule is that if one of the statements is true, then that's true. Okay? So false or false, so both statements are false. Then since this one, the second statement is true, so this is true. For this one, the first statement is true, so this is true. And in the last row, both statements are true, so this is true as well. Okay? And then we say that not P, the negation of P and Q is logically equivalent to not P or not Q by virtue of the truth table. Same. This means the same thing. Okay? Another one is for this one, for P or Q. These two are the De Morgan's laws for logic. Okay, then we have P or Q, so we simply copy P or Q over here, which is true, 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 and false, in same value lang na siya. We'll have the same value. So this is now true, 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 and false. And then to get the negation of this one, so you simply give the opposite truth value. So this is now false, 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 and then true. And then for the negation, let's go here. For not P and not Q, so we look at here. And since this is AND, so it follows the AND rule that it's true if both statements are true and false otherwise. If there's one false statement, then it's false. So for this one, since both statements are false, so this is false. For this one, the first statement is false, so this is false. This one, the second statement is false, so this is false. And lastly, both statements are true, so this is true. And now we say that the negation of P or Q is logically equivalent to the negation of P and the negation of Q. Since both have the same truth value. False, 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 true, true. The same table of values. Okay? So logical equivalence. So you create the table of values, and based on the arrangement of, and based on the results of the truth tables, if you're using the same values for P and Q, then if you get the same values exactly for all the rows, then these statements are logically equivalent. Okay? And lastly, we now go to your tautology and self-contradiction. Okay. So we have four examples here for tautology and self-contradiction. So tautology is a statement that is always true. A self-contradiction is a statement that is always false. And if it's a combination of true or false, then we call these statements as a contingency statement. Okay? So these things, all of these results, if it's a combination of true and false, then these are contingency statements. Okay? So we'll no longer give example for that. Then give example for tautology and self-contradiction. So for this one, since this is P and Q implies P, so we can transfer that over here. And then start with P and Q. Okay? So since P and Q is this value here, simply copy this one and paste it here, no? So this is now P and Q. And since this is P and Q implies P, this is a conditional statement where P and Q is the first statement and P is the second statement. Okay? So again, since conditional statement na siya, it follows the conditional statement. So you check for the true value in the first column and check if its corresponding value is true or false. And if it's false, then it's a false statement. But if it's true, then it's a true statement. So for P and Q, this is the only true value. So we check the P value here since this is the second statement. And since this is also true, so true implies true is now a true statement. And then, as discussed, if the first statement is false, we cannot actually verify if the statement is true or false. We can actually verify if the veracity of the statements. We assume that it's true. So since these are three, regardless of what is the value here in P, the statement is true. So since all of the statements are true, then we say that this is now a tautology. So if you're using the same statement, you say that Typhoon Upong is in the Philippine area of responsibility and it is raining hard, then Typhoon Upong is in the Philippine area of responsibility. And then we have here your Q implies P or Q. So again, let's transfer that over here. And then you copy P or Q over here since same na sila. So for this one naman, P or Q now is the second statement. So Q is the first statement. Okay, so Q, if Q then P. So we look at the true values for Q. So that's T and T, the first row and the second and the third row. And then we verify its counterpart here in P or Q. So for the first row, this is also true. So meaning this is true. And then for the third row, this is also true as well. So this is also true. Okay, so this is true and this is true. And then, since this is false, and again, regardless of what is the value for the second statement, if the first statement is false, then the conditional statement is true. So this is true. Okay? And now, since this is also true, then we say that Q implies P or Q is a tautology. So using that one, if it is raining hard, then Typhoon Upong is in the Philippine area of responsibility or it is raining hard. And so that statement is always true. So tautology. So tautology. And then lastly, we have this example, P or Q and not P and Q. So we're going to transfer this value over here. And then we're going to copy P or Q. Okay, so this is P or Q. And then you have not P and not Q. So let's copy that one as well. Okay. And this is now an and. Okay. So and if one of the statement is false, then the statement is false. So true and false. So that's false. True and false. So that's false. True and false. So this is false. And lastly, false and true. So this is false. Okay. So since all of the statements are false, so this is now your self-contradiction or your contradiction example. Okay. So again, if you're going to read this one, this is now Typhoon Upong is in the Philippine area of responsibility or it is raining hard. And Typhoon Upong is not in the Philippine area of responsibility and it is not raining hard. No? So that's two contradicting statements. So this is now a self-contradicting statement. Okay? And again, if it's a mix, then we call that one a contingency. Okay? So this ends the lecture for logic. You can read the rest. You can read the rest in the module and you can practice more before you do the activity for logic, which is actually also given in your LMS. Have a good day and keep safe, everybody.